All right, hello Algebra 2. This is day 1 of the 4A practice test for Algebra 2. Today we're just going to talk about graphing and axis of symmetry and vertex. And then our next video for day 2 will be all of our factoring. All right, so if I look at these three equations here, we have two different forms. Number 1 here, this is vertex form because they give us the vertex. Number 2 and 3 are standard form. And reminder in these, we have to find our vertex, okay? So number 1 here, we can answer all of these questions without graphing. So my axis of symmetry, reminder, that represents a vertical line. So I'm going to say x equals, and it's whatever number is here with the x, but remember you need to flip the sign. So instead of positive 1, it's going to be negative 1. That comes down here for our vertex. So I'm going to have negative 1, and then whatever number is at the back here, that is our y, so negative 3. Okay. Excuse me. So for max or min, we look at our number in front to see if it's positive or negative. Our number in front is a positive one, so that means it's going to make a U shape. So that means we have a min. Our domain for all of these for parabolas is all real numbers. Okay. And our range, so since I have a U shape, all of our y's are going up. So I'm going to say y is greater than, and remember you bring whatever number is here, you bring that down. So negative 3. Okay. So we can answer all of that without graphing. Now, when we're in vertex form, how we did these is we made a parent graph. And to make a parent graph, we're going to make a table off to the side here. And for x's, we'll have negative 2, negative 1, 0, 1, 2. And then we square all these numbers. So I'm going to have 4, 1, 0, 1, 4. And this represents my parent. So I'm going to have a point here at negative 2, 4, negative 1, 1, 0, 1, 1, and 2, 4. So this is our parent. And then we're going to take our parent and we're going to do the transformations. And reminder that transformations we take from our equation and this information that we looked at before. So that 1 means I'm going to go left 1, and the 3 means I'm going to go down 3. So now I'm going to take every single point on my parent, and I'm going to go left 1, down 3, left 1, down 3, left 1, down 3. And then we'll do that for every single point and connect them. So on your test, on your vertex form, I should see a table, a parent, and a new. So I should see 2 graphs on those. Okay. Now for number 2 and 3, these are in standard form, and we have a little bit more work to do, but at least we don't have to make a table. All right, so for these two, we have to find our axis of symmetry first, and I'm going to write this up here. Reminder, our equation for axis of symmetry is x equals negative b over 2a, and we're going to use that on several problems. So this first one here, I'm going to say x equals, notice our b is negative 4, so I'm going to flip the sign, so it's actually going to be positive 4 over 2 times 2. And when we plug that all in, we're going to have x equals 1. And reminder, we're going to take that and bring that down for our vertex. And then to find our y, reminder, I'm going to have to take my equation and plug 1 into every spot. And it's up to you how you feel comfortable. You could plug this whole thing into your calculator or use your brain. And when we plug this all in, we're getting negative 8. No, we're not. We're getting negative 7. There we go. All right. Now, again, we're going to answer these 3 questions. We don't necessarily have to look at our graph. This number in front, it is positive, so it forms a U, so that means we have a min. Domain is, again, all real numbers. And because we have a U, all of our y's are going up, and it's whatever number back here, so negative 7. Now, right now, if I'm not making a table, there's one other thing we have to find. Reminder for these two, The other point that's important is our y-intercept. And reminder, our y-intercept is 0, comma c. So notice there's no spot for it. You just have to remember that I have to find my y-intercept, and it's 0, comma, -5. And those are the only two things we're going to graph. So I have my point here at 1, -7, so that's my vertex. Now reminder, our vertex has something very important going through it. It has that axis of symmetry. So reminder, symmetry means whatever's on one side is on the other. So if I have my y-intercept there at 0, -5, so if it's one away on this left side, that means I have to have one away on this right side. And then we're going to connect everything from the vertex, and notice we have a U, and we said that was already going to happen. Okay, I hope you see the difference in those two and how we answered them. Okay, all right, we have one more in standard form. So again, I'm going to use the axis of symmetry equation. I'm looking at my B here, so I have to flip the sign. So I'm going to have -2 over 2 times -1. I'm going to plug that all in, and I'm again getting x equals 1. I'm plugging this down here, and then I have to plug in 1 to find my y. Notice this x in front, this x squared has a negative, so when you square this in your calculator, you're only squaring the 1, not the negative. So I'm going to have 2 times 1 plus 3. And so then when I plug that all in, I'm going to have 4. Now this time I have a negative in front, so we're forming an upside down U, which is a max. Okay. Our domain is all real numbers, but because it's upside down, it means all of our y's are going down. So I'm going to say y is less than or equal to, and again, whatever in this y spot, so 4. All right, now reminder, there's one point we're not going to tell you to find, but you need to know our y-intercept is 0, 3. Okay, and so now we're going to graph everything that we know. We know 1, 4. I'm going to draw my axis of symmetry through there to remind myself what's going to happen with my graph. I have this point here at 0, 3. And since I have a point on the left side, that means I have a point over here on the right side. And I'm going to connect them from my vertex. Right now it forms an upside down U, and we already said that was going to happen. All right, so on your test, you have to do one in vertex form and one in standard form. All right, the next thing you're going to do on your test is you're going to look at these vertex forms, and you're going to do this without making a table and without making a graph. Okay, so we're going to answer all these questions, but luckily we already did this on number 1. So reminder, your axis of symmetry comes from this number with the x, but you flip the sign. So I'm going to say x equals -3. You bring that down for your vertex. Whatever's chilling here at the end, that is your y. Our a in front is positive, so that means I'm forming a u, so I have a min. My domain for all of these is going to be all real numbers. Make sure you're getting that right. And our u is going up, so that means all my y's are greater than or equal to, and reminder, it's whatever number is here. Okay. Now, transformations, we haven't talked about this. So when we're looking at these, we're looking at these 3 numbers here. So the 2 in front means it's a stretch of 2. That +3 means we're going to go left 3. And the -5 means we're going down 5. So as you can see, we can do all of this without graphing or making a table. Okay. All right, let's do this one more time because this one's just a tad different. So again, I'm taking that number with the x. That's my axis of symmetry. So I'm going to say x equals 2. That's going to come down, be part of my vertex. So I'm going to have 2, comma, the number at the end there, so 7. This time, my a is negative. Therefore, I have an upside down u. So that means we have a max. My domain, it's still all real numbers. And our y, since it's going upside down, it's going to be all of our y's are less than, and whatever number's at the back here, so 7. All right, so because it's upside down and there's a negative in front, that means I have an x-axis reflection. The 3 means we have a stretch of 3. The -2 means we're going right 2 and then up 7. All right, so that's our 2 different ways of graphing and our vertex form doing that without graphs. Okay, we're gonna do one more problem and then the rest will be left for our video tomorrow. All right, so the last thing we're gonna talk about, because it kind of deals with what we did on the front, excuse me, we have this word problem here, but what it really is, it's like number 2 and 3 on the front that we're going to use our axis of symmetry and our vertex to help us solve everything. Okay, so we have pumpkins that are being flung in the air. Our catapult starts at 4 feet tall, and we have this equation where t represents time and h is our height. I'm just going to do a quick picture over here just to help us visually. So our pumpkin is starting at 4 feet, and then it's going to go up, and it's a pumpkin, so it's going to smash on the ground. Okay, our x is represented by time, and our y here is represented by height. All right, so the first thing we're asking you is when will the pumpkin be at its highest height? So on my timeline here, from the start to here, how long will that take? So that line that I just drew in is the axis of symmetry. So that's equation from the front. So I'm going to say t equals, we're going to say negative 36 divided by 2 times negative 16. Notice I put parentheses around the entire bottom there. Reminder, when you're finding these, we're representing time, so it should be positive, and also our answer shouldn't be ridiculously large. When we fling things in the air, they're not in the air for like 100 seconds. So when I'm plugging this into my calculator, I'm getting 1.125. And we're talking about time, and so we need to label this with seconds. Okay. And then we're asking you, what is that maximum height? So if I know this is my time here, I want to know what is that point, and reminder, that's our vertex. So I'm going to take my equation, and I'm going to replace all of my t's with 1.25. Okay, and this is where you want to grab your calculator and plug the entire thing in as you see it. Make sure not to miss the square here, and plug the whole thing in. And reminder, if you get a negative, it's wrong because it represents height. And if you have like a ridiculously large answer, it means you've done something wrong, because we can't fling pumpkins in the air and hit like 1,000 feet. All right, so when I'm plugging this in my calculator, I got 24.25, and it represents our height, so we're going to label it with feet. Okay. Now the last thing we're going to do is we say, what if our pumpkin hits a post that stands 4 feet tall? How long did that take? So there's a post here, and it hits it at 4 feet. So we're trying to find out how long it took from here to here. Now we already know the halfway point, so we're going to take our halfway point, which is this answer here, and we're going to double it since we know the halfway. Okay, and we're going to plug that into our calculator, and we are getting 2.25 seconds. Now, I want you guys to notice, A, we use this answer for everything. So if A is wrong, this one's wrong, and this one is wrong. So make sure you double check your answer. All right, good luck. I will see you tomorrow.